Hey everyone, this is gonna be summer 2021 midterm 2, and this is gonna be you've seen it all, question number 5. And so starting with part A, we have a function called memory store that's gonna return two functions, add val and time seen. As you can see from the doc test, like memory store returns two functions. If we call it add val of 4, it's kind of gonna like store it in the memory. So let's, for example, in this for loop, we add val 3 times, and time seen is going to tell us the number of times we've added the value 3. In this case, we added it 3 times, so it's going to return 3 right here. And we added 4 one time, and it's going to return 1. And taking a look at the skeleton code that we have like the return value of returning those two functions, okay? And we also have like these functions being defined right here, along with memory, which is a dictionary. And we have the idea that for some corresponding value that we add, for example, like this var1, we might be adding, we have like some number of values that like might we like that we have like seen it so far. And so that might give us the idea that memory should be a dictionary of like some key to some value, and this key is going to be the variables that we're adding, and associated with that key is going to be the value, and that's going to be number of times we've seen it so far. And what we can do with add val is we could take that variable and we can like add 1 to the number of times we've seen it so far, and in time seen we can like access the number of times we've seen it by like accessing like the dictionary through like some certain key, which is going to be var1. And keeping that in mind, let's dive into the problem. And so what add val of var1 is going to do is we have like an if condition here. And if var1 in memory, that we want to do something, otherwise we don't. And what we have to note about like dictionaries is that if we don't have any like values in the dictionary, and we say like var, like a dictionary of var1 plus equal to 1, because like let's say we wanted to add 1 to the number of times we've seen it, what's going to happen is going to error out because there's no key associated with it. And so what if var1 in memory is going to do? It's going to check, is there a key? Is there the key var1 inside the memory? And if there is, that's great. Then we can add 1 to it. And so filling in this line, we get that we want to add 1 to it. And so taking a look at all of these options, we see that memory of var1 equals memory of var1 plus 1 is going to add 1 to it. While the other ones don't really like do anything to like add it. And so that's going to be our option right here. So memory of var1, we're adding 1 to it. But if it's not in the memory, then what do we want to do? Well, if it's not in the memory, we have to initialize it. And to initialize it, we want to start off with the value 1. Because if we add val of var1, then we want to start off with the fact that we've seen that value 1 time. And so in the else statement, so in line B, we're going to say memory of var1 is equal to 1. Yeah, and that's going to be our add value function. And then moving on to the time seen function, we want to return the value number of times we've seen it, and that's just going to be like the key value, like the value corresponding to the key var1. And so we can do like a dictionary, memory, and it has a get function. And with that, we have some value var1, and we want to get like the value associated with var1, so that's exactly what we want. We also want the default value to be 0. And so what this is saying is that if var1 is inside the dictionary as a key, then we can get like the number of times associated with it. But if var1 is not inside the memory, then we're going to return 0. Because if not, it's not inside the memory, then like we haven't seen it at all. And we can also write this as saying like, you can like return memory of var1 if var1 in memory else 0 right here. And it's going to be the exact same logic. And yeah, that's going to be part A. And let's move on to part B. Yeah, this part will go in like line C. Alright, so moving on to part B, it's a bit of a trickier problem. And so this is going to be x casing d. And it has the same idea of memory, but it's like slightly different. And so add scene d is going to return a function in which we can like call it on 3, 4, 3. It's going to like store it in its memory. And then when we call this a function each time, it's going to tell us, it's going to print out like the sum of like all the elements that we've seen at least d times. And so in this case, we saw 3 once, like store in the memory. We saw 4 once, store it here. We saw 3 again, and we noticed that we saw 3 2 times in total. And if you notice, in our add scene d call, we pass in the value 2. That's saying we want the sum of all the values that we've seen at least 2 times, or d times. We saw 3 at least 2 times, and so our sum is going to become 3. And if we add another 3 again, it doesn't really change anything because we've always, like, it only matters like if we've seen like some number at least d times. And so like seeing it 2 times, 3 times, 4 times doesn't really matter. It's going to be included in the sum. But if we add 4, now we've seen 4 2 times. And so we're going to add that to our total, and that's going to be 7. And if we add 5, that's only seen 1 time, and like we don't add it, and it's going to stay 7. Right. And so one thing we want to like take note of in like higher order functions in general is the fact that we're calling this a function repeatedly. And it's going to be like storing the value each time. And we need to figure out what exactly is this a coming from. And so if we go to like the add scene d function, it's going to define this inner function and it's going to return it. And so this inner function, my pen glitched. So this inner function is going to be taking in some value that we want to store, and it's also going to be printing out like the number like times like the sum of all the numbers that we see like greater than or equal to d times. And along with that, it's also going to be like returning a variation of itself. And the reason why it returns like a variation of itself is that a is going to return another a, and we're going to call on a 4, so it's like going to keep on returning itself each time. And with that, we have like some sort of memory associated with it. And yeah, let's dive into this problem. And so one thing we might want to take a note of is a couple things. So we have some sort of print function, and we want to return something. And we also have this like new scene thing. And new scene is going to be called on some inner var. And we're comparing that to see if it's equal to d. Well, what we know about that is that d is going to be like the number of times we want to see something before we add it to the total. And so we might be wondering, we might be thinking that the new scene function is going to tell us how many times have we seen this number so far. But one question that we might have is that why is it comparing it to be equal to d? Why is it not like greater than equal to? Because if it was like greater than equal to d, then we want to include that in the number. Well, what we notice about like this like memory that we have so far, so like this is like the doc test, is that here is going to be 0, here's going to be 0, but then we saw 3 2 times, and we want to include that. And notice for like the rest of like all of our function calls of inner, that we're going to always want to include 3 in the total sum. And so that gives us the idea that once we've seen that we see the number d times, we want to always include it in the total. And the question is, what variable like includes like has like the total number? That's why we see the variable right here. That's going to be total equals 0. So that kind of makes sense. It's going to be initialized at 0, and whenever we see a number that like we've seen d times, we're going to add it to that total, and each time like we're going to keep on adding it to the total, and we're going to print it out each time. And so keeping that in mind, we kind of have the idea of what this print statement could be. And so it's going to be total, and we also want to include like the new number. So once inner var has hit d, then we want to include that number, so we're going to print total plus inner var. Yeah. But on the other hand, if we haven't seen it d times, exactly d times, we don't want to include it. And so because of that, we're just going to print total. And if you notice in this add scene d call, we only pass in total. And for part C, we kind of want a format similar to the else statement. because it's gonna have to return some variation of inner. And because we're like calling it repeatedly on 3, then 4, then 3. And so we can't just return inner, like right here, because what we notice about this is that it's not gonna have like record any sort of memory, because total is not gonna change. Total is just gonna stay 0 the entire time. And so that's why we need to follow like what the else statement did. We need to make a call to add scene D. And let's think about like what stuff we want. Add scene D of D, because no matter what, we want to check if like we've seen something D times, so that's not going to change. And there's a new scene function right here. Let's think about that in a sec. But then as for the total, we want to pass in a new total, so it's going to be total plus inner var. So we got that down, and we need to think about, no, what is new scene? Well, new scene is going to be a function that tells us how many times have we seen something. And we need to think about where it comes from, because I'm sure it can't be in like some sort of lambda, like some sort of simple lambda, because it can't like, it's going to be really hard for us to like write code that's going to like store the entire memory inside of that. So it has to like come from somewhere in the code. And so it can't be coming from add scene D, because that's going to return a function. I mean, an inner function that's going to like print out stuff. So it can't be that. It also can't be inner, because if we call inner on something, it's going to return a function. And we don't want to compare that to like D right here. So it can't be that. It also can't be make scene function, because that's going to return a function. And so it's probably going to be this scene function. And we haven't like figured out what it's going to return, but it's probably going to be that. And so to get this scene function, we have to make a call to the make scene function. And so it's going to look like make scene function. And then what exactly is going to be the f and the ms var that we pass in? So these two things. Well, if you notice with like the ms var thing, inside our scene function, we want to check if ms var is equal to scene var. And scene is going to be called on the inner var right here. Well, that kind of gives us the idea that maybe that's going to be our memory. And so if we want to store that in our memory, what we want to pass in is like the new value that we're adding. And so in that case, it's going to be inner var. So let's maybe make 2 lines right here. And then the second parameter is going to be inner var. But the question is, what's going to be the first parameter? And so if we think about like maybe our memory that we have so far, let's say we made a call to like 3 and 4. So I'm going to like make a list to like kind of represent our memory. But obviously it's like not going to be a list, because we're not allowed to like use lists in this function. And so our memory is going to be 3, 4. And what we notice about this, let's say we pass in a new value that's going to be 3 call. And so we're passing in the value 3 as our new memory. But the question is, how do we get our previous memory? And what I want to really point you towards is this add scene D call at the very bottom. And we're going to be passing in the new scene function. And so the new scene function is kind of going to be accumulated on each other each time. And so we're passing in some inner var each time. And then with that, we're going to have a new scene function that's going to like add the 3 to the memory. Because that's like the only place that we can like really store our memory, because D is going to stay the same each time. Total is just going to be a number. So scene fn has to be like our memory of all the previous things. And the scene fn function is going to tell us how many times have we seen like all the previous memories. So let's say we're inserting the new memory, the new value being 3. The scene fn function is going to tell us how many times have we seen it in like the first 2 values. And so taking a look at this, we want to check if is like the latest memory, ms var, equal to like the value that we're passing in, inner var. Well, if it's equal, then we want to return 1 plus f of scene var. And the reasoning behind this is that if we see 3 and it's equal to the value that we're checking, so like inner var, that means we want to like add 1 and to the number of times we've seen it in like the previous memories. That's going to be handled by the f function, which is like built on each other each time, and that's going to be like the previous new scene function. And then the thing is, if we don't see it, then we don't really want to add one to it, and we're going to return f of scene var. And so we got the scene function down, and let's head back to like the inner function. And so this make scene function is going to be building on like the previous function. We notice from the add scene decall being returned, we're going to be passing in scene fn, because scene fn is going to be like the previous new scene function from like the last call, and it's going to be building on the top of that each time. And then since we want to pass in that previous function, we also need to do the same thing for the add scene decall, and that's why we pass in new scene right here. And this might get pretty confusing as to like how this works, so I'm going to make a little drawing on what's going to happen. And so what we might have is in our first new scene call, we start off with like a lambda x0. So we start off with like the value 0 being a function. And then when we say like new scene equals make scene function that is scene fn and inner var, let's say inner var is going to be at 3 right here. We're going to make a new frame called m1. And by m, I'm referring to like a make scene function. So we're going to open up a new frame, and this parent is going to be the global frame. And we're going to say ms var is equal to the value 3. And inside of that make scene function, we define a scene function right here. And it's going to say, it's going to use, since it's defined inside of m1, its parent is going to be m1 as well. So the scene function, s1, its parent is going to be m1. And what it's going to do is, if we pass in some sort of value, like let's say scene var, so inner var, let's pass in like 4, because that's like the next call. Actually, let's just pass in 3. If we pass in 3, it's going to go like, is it equal to 3? Well, it is, so we're going to return 1 plus this f function. And notice how the f function is the lambda x0. It's going to go like 1 plus 0. And that kind of gets us like what we want. And if we build on top of each other each time, we're going to be defining new make scene function environment frames. It's going to be like m2 parent equals global, and then ms equals 4 if we think about like this call right here. And it's going to go like s2, whereas parent is going to be m2 because it was defined inside the m2 frame. And then we have like some sort of box, and these are all like referring to each other as parents. And when we call like a f of maybe 4, maybe it's going to go like, this is the inner var is equal to 4, so these are equal to each other. So we're going to go like 1 plus whatever like the f call is. And remember that the f call is the previous make scene function, and so that's referring to this function right here, the scene function right here. And if we think about that, it's going to go like, we're going to pass in the value 4 because that's the value we want to check like how many of those there are. It's going to like 4 is not equal to 3, so we're not going to add anything. And f, the original f function, is going to be 0, so it's going to be like kind of like 1 plus 0 plus 0, which is equal to 1, which makes sense because we saw that value exactly 1 time. That's kind of a bit into like how the scene function is going to work, how it's going to like build on each other each time. So each time it's going to open up like kind of a new environment frame, and that like environment thing, the make scene function, is going to be storing the value that we've seen in its memory. And each scene function is going to be calling the previous scene function, and it's going to be aggregating 1 each time according to like what the current memory is, where it's like defined. So in the first scene function, its memory is 3. The second scene function, the memory is 4. And it's going to be adding 1 each time depending on if they're equal to each other. Yeah, really confusing, but it's also like super cool because like normally like, this function, had like a memory that like kind of stored values. And like that's kind of like the usual way we store things through like a dictionary or like a list or all of that. But what's really cool is that we can actually use higher order functions to like store memory. And it's kind of weird because like we kind of like define a function that stores like a certain value, and we build like functions on each other to make a memory. And yeah, going into like the answer choices. So if you notice that part 5 is like select all that apply. Like our answer was 1 plus f of scene var. And let's check like what values do we want. So f of msvar and f of scene var don't really make too much sense because we also need to add 1 to it. So it can't be this, can't be these two, and it can't be those as well. Because this is like equivalent to like 2 times f of scene var or something. Which doesn't make sense. And also the bottom, like why would we subtract msvar? We just want to like add 1. And so we got that down, and we need to choose between these two. But the thing about that is that both of these actually work. And the reasoning behind this is that our if condition was saying that if msvar is equal to scene var, then we want to return 1 plus scene var. Well, if that condition is true, that means msvar is equal to scene var, and so these are like kind of interchangeable, and we can like use both of these options. On the other hand, if we go to like the else statement, we always have to return f of scene var because if we call f of msvar, there's no guarantee that they're equal. But yeah, this is going to be all of xk scene d, and yeah.